not cover all of lesson 6.1 today. We will cover part of it today, and then we'll move on to the rest of it tomorrow. Here are the things. I'm going to start out with a couple of conclusions you should have been able to make after doing your own note-taking yesterday and studying this lesson. So, taking a non-zero number to a negative power, you should have discovered it does not make the answer negative. And it's tempting to think that it will. Because it's to a negative power, we think, well, then that must mean it's going to make the answer negative. Did that ever happen? No. In the homework that you did or the practice that you did it ever, when you had something to a negative power, that first of all, maybe when we just talk about the negative power part itself, I'm not talking about the fact that maybe there was a negative sign involved somewhere else in the problem. But as the negative sign part of the problem, that should have never made that expression a negative number. So a negative power does not make it negative. What does it do instead?
Makes it a fraction.
Makes it smaller, makes it a fraction. It makes it smaller, not negative, but it does make it smaller. Okay, the other thing that is very tempting to say is, what if you're taking something to a zero power? Taking a non-zero number to a zero power does not make the answer zero. No, it does not make the answer zero. And it's tempting to think that because it's to the zero power, when there's powers going on, there's multiplying going on. And multiplying by zero, of course, creates zero, doesn't it? But when we're taking something to a power, are we multiplying by that exponent? No, that's not what that exponent is telling us. So we do not get a zero when we have a non-zero number taken to a zero power. Okay, here's what we can count on then. We're going to let x be our base when x does not equal 0. What can we always count on for x to the 0 power then? What will x to the 0 power, if it's a non-zero number, Jacob, what will it always equal? 1. We can always count on that anything to the 0 power, as long as it's not 0 itself, is 1. And that includes variables that we don't know what they're standing in for. All we have to do is say, okay, but that variable can't be 0 itself. What can we count on always for when we have that variable being taken to a negative power, or n is the power, we're saying it's a negative n. What can we count on if we have a non-zero number? Well, how can we rename x to the negative n power? How can we rename that? Somebody want to offer up exactly what I should write here, Courtney?
1 over xn.
Yeah, 1 over x to the n power. Not quite xn, because that would be x times n, but x to the n power. 1 over x to the n power, and notice that power is no longer what? Negative. That's how we get rid of the negative, because they say that expressions are not simplified if there are 0 or negative exponents in it. And then our last one, what if the negative power is in a denominator? How can we rename 1 over x to the negative n power? How can that be renamed? Look in your SQ3R, see if you have any hints to yourself in there. 1 over x to the negative n power, how can that be renamed? Not negative 1 over x to the n power. Jacob?
X to the other power.
X to the
And then over 1.
okay, x to the nth power over 1. In other words, the trade's floor was with the numerator. And now it's a positive power. And that can be even simplified a little bit further and be just what? X to the n power. So we can rename, when we have a negative power in the denominator, we can rename that. It comes upstairs into the numerator and ends up being a positive power. Okay, and then here's some other things I just want to make sure. We kind of started talking about this yesterday when we were correcting that assignment at the beginning of class yesterday. When are we going to know when our answer should end up positive or it should end up negative? And it's all according to how it's written. So I say right here, when it's written negative 2 to the fourth power, no parentheses involved, it does not mean the same thing as negative 2 to the fourth power. And we started evaluating that yesterday. We said that negative sign is not taken to the power. It means what?
It will be negative.
What word phrase did I say we can substitute in? The opposite of. So we're really saying the opposite of 2 times itself 4 times. Well, 2 times itself 4 times is 16, and the opposite of 16 is negative 16. So when we don't have any parentheses involved, we can see, oh, we're going to end up with a negative 16. But when it is parentheses are around, the negative sign has been included with that 2 now. Now it is saying that we're going to take negative 2 times itself 4 times. And what is negative times a negative times a negative times a negative? Positive. And 2 multiplied 4 times, we already said, is 16. Negative 16 and 16, are they the same? No, they're really not. They're not the same number. Only in the world of take your pencil and erase a negative sign when you don't want it there and add one when you want one there, right? That's in the world that they mean the same to you guys. But in reality, negative 16 and 16 are not the same number. Okay, I want you to evaluate. I want you to show the work that supports what your answer will be for this last one. I want you to evaluate the expression that is given here for you according to what we just talked about. Show your work. Don't use your calculator. Anyone want to offer up to come up and show it on the smartboard instead of me? No takers. Did you get the same answer right?
Yes.
Because we can't get negative 8, that's not the same thing, right? Okay. So, but be careful. You might be tempted to think, don't do this. And this is what you're going to be tempted to do with powers. And you see 2 negative signs. When we are subtracting a negative, we change that to add the opposite, don't we? And make it plus plus. Don't do that here. Don't say, well, right away in the very beginning, there are 2 negative signs, so I'm just going to make that positive right away to begin with, and then I'll just take 2 to the 3rd power. Let's see if that works when we do it this way. Let's evaluate this one now. Let's do negative 2 to the 4th power. Will you evaluate that one now, please? What happens when you do the new expression I have up there? Any takers for negative 16? Okay, now, notice, what if we had instead, right away at the beginning, said, you know what? Oh, there's 2 negatives beside each other. I'm just going to change those to plus plus, and then I'll just take 2 to the 4th power. What is 2 to the 4th power? 16. Is 16 the same as negative 16? No, so we have to be careful how when we're dealing with powers and negatives, we have to understand what's really going on. We can't just say, oh, well, all along we've been doing subtract a negative can be changed to add a positive. There's no addition going on here, folks. There's only multiplication going on. Okay? So any questions? This is just kind of like a summary of, like, what are some of the things we should have learned so far in this lesson that we can now apply? Okay, then let's go to the back side. So notice, you will get problems marked wrong on quizzes, tests, standardized tests, doesn't matter where you are. If you think one of the answer that you choose is correct, when it still has a negative exponent in it or a zero exponent in it. It's not simplified yet. Just like if you start with, let's say, 50 over 100, and you first simplify that to 25 over 50, and you think you're done. Are you done? No, and then you simplify it to 5 over 10, and you think you're done. Are you done? No. And then you simplify it one more time to what? 1/2, which you could have probably gotten to right away, but maybe along the way you're simplifying a fraction and you think you're done, but it's not simplified till you really are done, until there's nothing else that can be divided out of the numerator or the denominator. Well, same thing goes with expressions when we're dealing with zero and negative exponents. They cannot have, your final answer cannot have a negative or zero exponent in it. Okay, so here we are doing some check it out problems. 10 to the negative 4 power, we're not going to put that in our calculator. We're going to do what? Rename it using those rules we had on the front. When you have x to a negative n power, it can be rewritten as 1 over x to the positive n power. So how could we first write this? 1 over 10. Yeah, so this can become 1 over 10 to the 4th power. And then you don't really have to show what 10 to the 4th power means. What does 10 to the 4th power mean? 10 times. Yeah, 10 times itself 4 times, right? You don't have to show that, but here's what you, so what is 10 to the 4th power? 10,000. So we would say our final answer is 1/10,000. And chances are, if you put that into your calculator and did it, it would give it as a decimal. You want to check it out and see? And 1/10,000 as a decimal, I believe, goes like this, 0.0001. So is that what you got? Do you think that's how I want you to do your homework, though? No, you're right, I don't. I want you to show this, that you understand how it becomes 1/10,000. And that, the calculator just gave you another name for 1/10,000. It gave you the decimal name. We're going to give the fraction name instead, okay? Okay, so let's write the next one as a -2 to the negative 4 power. How can we first get rid of that negative power? Put it downstairs, okay? So what's going to go upstairs then? 1. Okay, so we have 1 over -2. Are those parentheses important?
Yes.
Very important. Don't ditch them. They're not ready to be ditched yet. We're just ditching the negative exponent. That's what we're getting rid of. And now we're going to say, oh, okay, -2 times itself 4 times is 16. So we end up with the answer 1/16. Okay, again, these are ones that you should already have done in your check it out problems if you want to check it out and see how you did in your SQ3Rs. So questions so far? Okay, then let's do the next one. What's its first step gonna be? It's gonna go downstairs, it's gonna look just like the last one, except this time it's gonna be to the 5th power instead of to the 4th power. 2 to the 5th power, in other words, take 16 times 2 again because we have one more time. What is it? Okay, so it's 32, but negative times a negative times a negative times a negative times a negative is a negative. Okay, so we have 1 over -32, but we're not going to leave that negative sign downstairs. We know that we can do what with it? Move it outside. I mean, it doesn't, when a numerator or a denominator are negative, one of them is negative, make the whole fraction negative, rather than leaving it where it's at. If both of them are negative, what do we do?
Make it positive.
Make it a positive. The fraction is positive then, isn't it? Okay. So, how are we going to treat this one when there's that negative sign is not in the parentheses with the 2?
Just going to treat it like 2 to the -5th power. The negative.
So in other words, this is really a negative sign, and then we have 2 being raised to the -5 power, right? The opposite of 2 to the -5 power. So now we could say, okay, the opposite of what? 1 over 2 to the 5th power. And the opposite and the opposite sign still comes along. We're still saying the opposite of because we're not done yet. 1 over 32. And then what is the opposite of 1 over 32? I know it kind of looks like it already. You're like, what are you asking us for? That's going to be the same thing, isn't it? The opposite of 1 over 32 is a negative 1/32. So we got the same answer as we did up above when the negative sign was with the 2 in parentheses. But be careful, don't think that that's going to always be true. Because what do you think makes a difference? The parentheses make a difference, and what else? The negative sign, okay. How about the power? What happened here when the power was this? Does it have? You know what? Did you know that negative numbers can also be even and odd? Okay, so this one, both of them started with what kind of a power? An even or an odd power? An odd power. Oh, and when they both started with an odd power, they still ended up with the same result, didn't they? Whether the parentheses were there or they weren't. Do you know a time when it won't happen like that? We've already done one in our work here. On the front side. Go back to the front side of your book. Is there? Third time, maybe we didn't totally practice. I bet I'm thinking of the note of the homework. Do you think of a time that possibly, in reality, the parentheses are really a huge issue and we can't forget about them? We're always going to worry about them, but anybody been able to come to a conclusion yet about? Okay, I think you will eventually then. Well, let's wait till you get there. Okay, let's go to the next check it out problems, where we are now evaluating an expression for a given value for the variable involved. So we are to evaluate p to the -3 for p equals 4. So we just substitute our 4 in for p and keep practicing what we've just been doing. So Devin Anderson, how am I going to rewrite 4 to the -3 power?
1 over 4 to the 5th power.
Yeah, 1 over 4 to the 3rd power. Anybody in here without your calculator, you know, you're ready to let your brain work? Know what 4 to the 3rd power is, Jared? 64. 1 over 4 to the 3rd power is 60, or 4 to the 3rd power is 64. So 1 over 4 to the 3rd power is going to become 1/64. Okay, there's our we evaluated for the given value. Okay, I remember helping some students when they were SQ3Ring yesterday. This one. 8. I'm going to put multiplication signs in there because it's what it really means. 8 times -2 to the -2 power. Anybody see a problem with what I just did? Jacob?
You didn't include the b value.
Well, okay, I'll put that too then. I'm going to put 6 to the 0 power. There's still something wrong here. Chaser? You don't know? That you had your hand up, I'm sorry. Jared?
-2 needs to be in parentheses.
That -2 needs to be in parentheses. Don't you dare substitute a negative number in that's going to be taken to a power without putting it in parentheses. Okay, now below that we're going to simplify anything that can be simplified. Can 8 be simplified? No. Leave it 8. How about negative 2 to the negative 2 power? Let's just, in steps, what could be our first simplifying step for that one?
Put it under a 1.
Okay, so 1 over negative 2 to the positive 2 power. So the base stays the same always. The only thing that happens is the exponent changes to its positive. And then what can 6 to the 0 power? Can that be simplified?
Yes.
To what?
1.
To 1. Okay. So now I'm going to say, since I got a fraction in the middle, I think I'll make my integers that are not fractions into fractions. So 8 can be put over 1. Negative 2 squared is negative 2 times negative 2. 4. And 1 can be made into a fraction by putting it over 1. And now we will multiply across, or you can simplify before you multiply across. Doesn't matter. We should all get the same answer. So 8 times 1 times 1 is 8. 1 times 4 times 1 is 4. 8 over 4 is 2. Okay, that's what you should have got when you worked it yesterday on your own. And those are the steps of work we would go through. Any questions at this point? Any concerns that are like, could I do this instead? What's the deal here? Okay, in your homework there's going to be some fun ones like here. Find the missing value. 1 over 25 equals 5 to the question mark power. We're looking for what power would that be. So how are we going to show work for that? Well, we're going to take the one that was given to us and we're going to rename it. So how can 1/25th be renamed? So 1/25th can be renamed as, I mean, it looks like we're going to have to deal with the power. Can we rename that first of all with a power downstairs?
Yeah.
What could 25 be renamed as?
5 squared.
5 squared. So we first are going to rename it as 1 over 5 squared. Well, 1 over 5 squared, came from 5 to some power. What power did it make? Negative 2. Yeah. So this is really the same as 5 to the negative 2 power. So did we find our question mark?
Yes.
Okay, our question mark is negative 2. Yeah, we found our question mark. 5 to the negative 2 power is the same as 1/25. Anything there you want to talk about? Okay, again, we're going to start with what we know, not the part that has the question mark in it. And we're going to say, okay, how could I rename 2 to the negative 3 power is the same as
1 over 2.
1 over 2 to the 3rd power. Well, 1 over 2 to the 3rd power is the same as 1/8. Do we have our question mark? Yeah, they're looking for what over 8. So our question mark equals 1. We found the missing value. Okay, one last one. We have 2 times 3 to the negative 2 power equals 2 over question mark. Well, you know what I'm going to do, right? I'm going to take the stuff we know, and I'm going to work with that. So if we say 2 times 3 to the negative 2 power, how can we rewrite that? 2 over 1 times 1 over 3 to the 2nd. So the 2 doesn't need to be renamed. I renamed it as a fraction, I guess, by putting it over 1. 3 to the negative 2 power becomes 1 over 3 squared. And then 1 over 3 squared can become 1 over 9. And then we'll just multiply across now. 2 times 1, 2. 1 times 9, 9. Do we have our question mark?
Yes.
Yeah, that's what they wanted. 2 over what? So our question mark equals 9. The missing value is 9. Okay. And that's where we're going to stop today. We're not going to deal with those simplifying algebraic expressions. We're just going to deal with the numerical one. And then the algebraic expressions where we would substitute into and evaluate. Okay? So you